Hey everybody, this is Mr. McKee again with Net 125. Today I'm going to be going over Packet Tracer 11.5.5, which is Subnet and IPv4 network. Alright, while I'm looking at it, I'm going to make this a little bit bigger. Let's see, that looks good. Alright, now on the Packet Tracer workspace, make this a little bit bigger too. Alright, just notice, looks like we have three LANs, LAN A, LAN B, and like an ISP router, an ISP switch. So this is internal ISP. Notice a routable IP address. Routable IP address, or when I say routable, I mean internet routable. All right, address. Notice the interfaces are down coming from the customer router. So the customer router goes through a serial connection to, which is like a WAN connection, to the ISP router, and then on the internal ISP network, they have a switch and workstation and a server. All right, and it looks like, let's see, customer router. Looks like we might be missing some IP addresses here for the customer router, the LAN switches, and the PCs. Alright, it gives us a bunch of information over here. Alright, notice there is 24 questions answered, which I labeled those. Alright, so in this packet tracer we're going to design an IPv4 network subnetting scheme, configure the devices, and test and troubleshoot the network. In this activity, you will subnet the customer network into multiple subnets. The subnet scheme should be based on the number of host computers required for each subnet, as well as the other network considerations like future network host expansion. After you've created a subnetting scheme and completed the table by filling in the missing host and interface IP addresses, you'll configure the host PCs, switches, and router interfaces. After the network devices and host PCs have been configured, you will use the ping command to test for network connectivity. Alright, so I've got up, let's see, alright, so this is the, I've also got my, alright, notice right here we have some configurations we got to do, so that'll be part of the grade. So you need to submit a .pka file, a screenshot of your results, or you can show that, and then also the instructions. Right, so I'll move this off the screen. I'm gonna get this thing, if I can grab it. Come here. Come on. Alright, there we go. Alright, now let me snap this thing. Alright, there. Alright, so we should be good. Alright, so part one is subnet the assigned network. Create a subnetting scheme that meets the required number of subnets and required number of host addresses. In this scenario, you are a network technician assigned to install a new network for a customer. You must create multiple subnets out of the 192.168.0.0 network address space to meet the following requirements. The first subnet is the LAN A, which is the top right, or I'm sorry, top left. You need a minimum of 50 host IP addresses. The second subnet is the LAN B network. You need a minimum of 40 host IP addresses. You'll also need at least 2 additional unused subnets for future network expansion. Okay, variable length subnet masks will not be used. All of the device subnet masks should be the same length. Alright, so that makes it a little bit easier, but we're going to need to split everything up. Now, I caution you if you try to use a like a web-based subnet calculator, because you don't learn how to do anything by doing that. All right, but I like to do it the old-fashioned way. I know in previous videos I did hex to binary. Like if you wanted to do an IP version 6 address, I showed how that was represented in hex. We're not going to do that today. We're just going to do IP version 4 address. So I'm actually going to create this thing while I'm thinking about it. IP version 4 subnetting. And if you create your own one like this helps you learn it even better. Alright. And what I want to do first, let me think. I would say let's do all of our individual bits, because we have 32 bits in an IP version 4 address. Alright. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what I'm going to do, I'm going to fill this thing in, and I'm going to be right back. But this is how you start it. You can duplicate what I do, but whatever way it makes you learn the best is fine. But I'll show you a couple little tricks here. All right, so I went ahead and made just a spreadsheet for IP version 4 subnetting. Okay, first thing I did, really the first thing I did right here was I just typed out all my 32 bits. Notice here they're all separated by dots. Each of these has 8 bits, alright? And keep an eye on the sum right here. That might help us out. Alright, so that sums that up. That's 32. Alright, I went through here and put in addressing. Alright, so if you had just one bit, it has 0 and 1. So that starts with a 1, and then it goes to 2, and then it just keeps doubling. Alright, and now if you think 8 bits, or 2 to the 8th power, is 256. That is all of these numbers added up. Notice how that has 255, and then you start counting at 1. Alright, and that's why I don't really like putting decimal. I rather put just addresses, because sometimes that's confusing. Like even in decimal, 0 is your first number, but it stands for really nothing. When you're talking about binary and addressing, the 0 is a number, is a valid number, but it just means the very first address, more than likely in your list. And a lot of times, .0 is your network address. All right, not a usable subnet, not a usable host address. All right, so you add all these up, and it comes out to 255. There's actually 256 addresses total. So just remember that. All right, and then if you go to the number of hosts, that's going to be the number of your addresses minus 2. So if 2 minus 2 is 0, that really doesn't make any sense. So the first 2 bits really don't have any hosts. All right. Sometimes you'll see a \32, and all that's representing the host itself. Like if you see 255.255.255.255 for the subnet mask, that's saying only use that specific address. Don't use any other addresses. All right, but we're not going to worry about that right now. But now, if you're talking about CIDRs, you've probably seen in some previous packet tracers, you see a \30, which is a 255.255.255.252. All right, and notice 252 plus 4 comes out to 256. All right, and often this is used for routers, because if you have a router-to-router connection, you have 4 possible addresses for a \30, but you only have 2 usable host addresses, because you got the network address, 2 usable host addresses, and your broadcast address. So that takes up all 4 of your addresses. And then from here, it's pretty easy, because if you just count up these numbers, minus 2 for each of these, for your network address and broadcast address, those all are just, you just take 2 away from your number of total addresses. Now the problem is, though, when you start using subnets, because like if all these are, if you see like in Netacad, notice how you'll have your network address, and that has all ones, and let's say start out with a \25. All these are network addresses, but then this would, if it was a \24, that would have an H. It would be all host addresses. But what you're doing is you're taking up this address to make two subnets. All right, but two subnets, and then you can only have up to 126 possible usable host addresses. So you have to remember that now you're actually not really wasting. You're not able to use, you would normally have 128 addresses times 2 to make 256. But since you're splitting it up in two subnets, each of those subnets is going to have its own host address, or its own network address, and its own broadcast address. So really you used up 4 addresses. All right, and then down here you're using up, say if you used another bit for subnets, and usually this is represented by an S. Instead of that N, you have an S right there to say, okay, it's not really a network address, it's not really host addresses. And when that says host addresses, that's usable host addresses. All right, you have an S right there. So if you used up 2 bits, and if you notice, if 2 bits have 4 possible addresses, each of these can be a 0 or 1. So 0, 1, 0, 1. Add up all 4 of those numbers, or all 4 of those numbers in binary, you'd have 4 possible subnets. So each of those subnets, instead of being 64 normally, you're using up 2 per subnet as your network and your broadcast addresses. So you're actually losing 8. All right, you're losing 8, you're losing 16, you're losing 32, and so on. Which can't really do anything about that, but just realize that that's what's happening there. All right, and also, I don't know why they didn't do it here. Maybe I don't know if they do it somewhere else, but normally, especially because this is a normal Class C address. All right, using the 4th octet for host addresses. If you start borrowing these bits, however many bits you borrow, that N will be an S, just to designate that that's subnets. All right, you just got to get used to. We're used to reading from the right to the left in binary, but now when you start borrowing bits for subnetting, you have to start from the left, just to the left of the dot though, or the period. All right, you got to move that way. All right, and also if you notice these numbers, there's 256 possible addresses. If you borrow 1 bit, it goes to 128, so that's half of that. And then if you notice, if you do half of 128, that's 64. 128 plus 64 is 192. All right, so that's a difference of 64. This is a difference of 32. This is a difference of 16. This is a difference of 8. And this is a difference of 4. So if you can memorize, and it's very good to memorize that for, say, for the Cisco exam. All right. It doesn't show it here, but like, say if we borrowed 1 bit from our class, we're just using this 4th octet. If we borrow 1 bit, it's 128. If we borrow another bit, 192. Borrow 1 bit, whoops, 192. If I can type 192, all right, 224, 240, 248, 252, and they do have 254, 255. We don't really use those though. That's what your subnet mask would be though. All right, if you borrowed a bit right here, you have 2 possible subnets. Each subnet would have this, and your subnet mask for each of them would be 128, and these would be 255. Let me just put 255 there. I know it's going to mess up my formatting. 255 and 255. I'll just put subnet mask. And that's more or less just memorization, because in my head I can't really do half of 256, half of 128, half of 32, half of 16. You just remember 128, 192, 224, 240, 248, 252, 254, 255. I do that. And matter of fact, when I take my CCNA exam, they give you a little dry erase board. I'll write down that on there first thing. All right, they let you do that. Also, I'd write down, notice all these citers, these all correspond to these numbers. So if you write those down together, you can memorize that, remember that. All right, you can also remember this. But just remember, we're looking at this. This is the number of addresses that you can use per bit. All right, the way this calculates out, all right, 128 plus 64 is this. 128 plus 64 plus 32 is this. 128, and actually, if I highlight it, see 240. All right, that equals up to 240. The next one equals out 248. Next one equals out 254. If I user error, all right, and then if I add all these up, that adds up to 255. All right, you'll never see a backslash 31. You'll see backslash 32, but normally router to router is a backslash 30, and then all these other ones you'll see quite often. And matter of fact, another thing to think about, even if you have a Class A address, say if an ISP assigns you a Class A address, because they're a really big company that has a lot of IP addresses to give out, they're not going to give you a Class A address with millions of possible addresses that you can assign to users. They're going to give you they're going to chop all those up and give you maybe a backslash 29, and that gives you 8 addresses. 2 of them are taken up, so you only have six usable addresses. And in real life, one of those addresses will also go to their router, so you only have 5. But if you need more addresses, they'll give you like a backslash 28, and then you'll have 14 addresses. But anyways, that's how that ends up. Now, when we do variable length subnet masking, this is going to be a lot more important to understand. But for now, I just wanted to show you guys how that works out. And over here, I just like putting in, I always draw this little spreadsheet every time I take the Cisco exam. Anything I know, like usually they'll give you an IP address and maybe a subnet mask. All right, so I'll put the subnet mask in. They might give you a network. All right, and then I can look down here and figure out if they ask me what my first host address is. Actually, let me put host. Last host address, and then broadcast. And you'll start to pick up on things. Network address, that's never never an odd number. So if you come out with an odd number, that doesn't make any sense. Subnet is subnet, but first host address, if your network is never an odd number, your first host address is always an odd number. All right. Last host address is never an odd number. Broadcast is always an odd number. All right, so you just remember that. All right. Okay, now that we know all that stuff, we want to go back and check this out again. Okay, so you must create multiple subnets out of a 192.168.0.0 network. All right, so we know that our network is going to be 192.168.0.0. And a lot of times I don't put these dots in here, but they sure make it a lot easier to look at. All right, we don't know a subnet yet, but let's keep going. let's see what we can figure out. All right, it's \24. All right, so knowing that, we know what we have to work it with is this 4th octet. All right, which is \24. It says \24 is there, but that just means all 24 of these bits are taken up as host addresses. We cannot use any of those for addressing or subnetting. All right. So the first subnet is the LAN A network. You need a minimum of 50 host IP addresses. So if I go up to my little, I don't like to call it a calculator, but if we notice, how many addresses will we have? All right, there's 64. All right, so we need 50 total. So that would give us 64. But if we add all these up, all right, that'll give us 63 plus 1 is 64. All right, so we could actually, let's see, one subnet needs 50. That would give us 50. Second subnet's 40. That would definitely give us 40. Let's see, variable length subnet mask will not be used. All of the device subnet masks should be the same in length. You also need at least 2 additional unused subnets for future network expansion. All right, so looking down here, I'm going to highlight this for now. We know that looks pretty good. All right. So if we had a subnet that had 64, 63 plus zeros is 64. I'm sorry. All right. And if we look up here, if we use both of these bits, all right, this has a 0, this has a 1, this has a 0, this has 1. So that would be 64 possible addresses times 4 subnets. All right. So we're going to borrow 2 bits. All right. So this is basically, if all these were n's, this would be an s, this would be an s, and this would be host, 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 host. All right. And all these are n's. And so on. All right. They go up that way. We're not really going to worry about those for right now, but all right. So now what we need to figure out, if we think that's the case, I'm going to say these are my subnets. All right. And don't really worry about those numbers right now. All right. We're just worrying about these numbers for hosts. All right. So how many hosts are needed in the largest required subnet? How many hosts? Okay, so 50 hosts are required in our largest subnet. What is the minimum number of subnets required? 4. All right. So we have 2 there. Each of these would be 2 subnets. So because you'd have a 0 or a 1. Just thinking about binary. All right. The network that you're tasked to subnet is 192.168.0.0. What is the \subnet mask in binary? All right. So we know that. All right. In binary, all 1s would give us, that would be the same thing, like all these are 1s. That would be the same thing as all these. All right. So in binary, it would be 255. All right. Remember, if it's in decimal and you're adding up 256, that would be 256. But in binary, it's actually 255. All right. Because if you added all these up, they would add up to 255. All right. Let's see. So in binary, it'd be all of these would be all ones, dot all ones, third octet would be all ones, and since all these are host addresses, notice 24 stops there, all of these would be 0. So it would be 8 ones dot 8 ones dot 8 ones dot 0000. This is just here for explanation, but it would actually be 0.0.00. Whoops. That would be \24. And that, remember, that means 24 of those 32 bits are host addresses. Or I'm sorry, not host addresses. 24 of those are network addresses, denoted by N, and then the last octet are all going to be host addresses, so you can use those. So 0 are usable, 1s are not usable. Okay. So let's see, the subnet mask is made up of two portions, the network portion and the host portion. This is represented in the binary by the 1s and the 0s in the subnet. In the network mask, what do the 1s represent? Alright, you can explain that. In the network mask, what do the 0s represent? What I just said. Alright. So 1s are not usable. Alright, they're all network addresses, and the 0s are usable. Those can be all host addresses or just addresses in general. Alright, so to subnet a network, bits from the host portion of the original network mask are changed into subnet bits. The number of subnet bits defines the number of subnets. Given each of the possible subnet masks depicted in the following binary format, how many subnets and how many hosts are created in each example? Alright, so we got to look through this. Remember that the number of host bits to the power of 2 defines the number of hosts per subnet minus 2, and the number of subnet bits to the power of 2 defines the number of subnets. The subnet bits, shown in bold, are the bits that have been borrowed beyond the original network mask of 24. The \24 is the prefix notation that corresponds to the dot decimal mask of 255.255.255.0. Alright, so it's pretty much just going down the list. Alright, so \25, that means a \24, which would be 3 octets of 8, all with 1s, and then you borrowed 1 bit. Alright, so number of subnets, one subnet can be the 0, and one subnet can be the 1 of this 25th bit. Right, and then if you add up all the rest of the bits possible, which right here, this is what it's talking about. You're borrowing 1 bit there, so what do you have left over? All right, you have 127 plus 0, 128 addresses. All right. Now don't get confused with addresses and subnets and hosts. You have 128 addresses times 2 would be 256. So number of subnets is 0 and 1. That's 2. Number of hosts, and this is how it gets tricky, and this is how they trick you. All right. If you add that up, and I've got that all. Is that ended up wrong? No, not really. All right. So if you had 25, it'd be right there. So number of hosts, it would be 128 minus 2. All right. Gives you 126. So number of hosts, 126. Dot decimal subnet mask. And what that means also, that's number of hosts per subnet. All right. They should have put that. Number of hosts would be like host in both subnets. They didn't really specify that. If that's actually, if they grade that differently, that's fine. Just understand that you got to be more specific than that. You got to say total number of hosts over the both subnets, or number of hosts per subnet, because that's going to be different. It's going to be double. All right. So \26, which will be right here. And notice when I say \26, that means this is a subnet, this is a subnet. All right. And I'm going to get rid of my colors because we're changing stuff. All right. So \26 is right there. All right, number of subnets. So you have 2 per. So 2, 4. All right. So you got 4 subnets. Number of hosts. So 63 plus 64. 64 possible addresses, and then -2 for your network and your subnet, in your default, your network and your broadcast address. So you'd have 62 per. So 62 times 4 if they're being specific. All right. So 27. So if it's a \27, all right. Number of subnets. So it'd be 2, 4, 8. All right. See subnets 2, 4, 8. And number of hosts. So it'd be 32. Possible addresses -2 is 30 hosts per subnet. All right, \28. So we do this right here. All right, number of subnets, 2, 4, 8, 16. All right. And notice 16 times 16, don't get that confused. 16 times 16 is 256, so that adds up right. And then you have 15 plus 0, 16 possible addresses, so 14 hosts addresses per subnet. All right, \29. All right, number of subnets 32, and you can count these up: 2, 4, 8, 16, 32. All right, each of the 32 have 7 plus 0, so 8 usable address, or 8 addresses, 6 usable host addresses. So notice that right there. All right, and then a \30, which is this right here. All right, so 64 subnets possible, and add these up: 3 plus 0 would be 4, and then -2 is 2 addresses. And remember, \30, that's normally almost always router to router, because all you need is an interface on each side connected to each router, and then a network and a broadcast address. And I know I'm going through this a lot, but we're going to go through this a lot more too, because this takes a while to understand this. So if you're not getting it, if it's like, wow, this is too much right now, just let it sink in, redo it. If I don't do it for a while, I have to revisit it myself. All right. So we're there. And also, just to verify, I had this up anyway, so I might as well show it to you. In Netacad, it does a good job of explaining. This is everything on the \24 network, Class C address. All right, \25. Make sure subnet mask that. And all that's saying is it's this one, which is the 128 address. It's taking that. All right. Because if it was a 255.255.255.0, that's the same thing as 256, the 256th address, right? Which is actually, yep, it's 0. All right, so it shows you here this, and so on, down boring 1 bit, 2 bits, 3 bits, 4 bits, 5 bits, 6 bits. Remember, it stops at \30 because anything past that is not a valid subnet mask. All right, and then kind of explains how to do it down here also. All right, but do not use calculator, because calculators, you're not going to have that on the certification exam, so don't get used to using it. It makes it too easy for you. All right, and you don't really understand it. All right, so considering your answers above, which subnet masks meet the required number of minimum host addresses? So we need at least 50, all right? So if we need 50, we need to go up here and say, okay, 50 addresses. I'm thinking a \26 would give us 62 host addresses, 4 subnets. All right, if we went to a \27, that would only give us 30 addresses per subnet. It would give us plenty of subnets, but not enough hosts. All right, so I'm going to say a \27. All right. Let's see. Considering which subnet masks. Okay, so we're saying a \27. Considering your answer above, which subnet masks meet the minimum number of subnets required? The minimum number of subnets required would be actually a \26. Or actually, I'm sorry. Yeah. Because that would be 4. Wait, let me make sure I'm getting that right. 25 is 128. Yeah, \26. That's what we want. Because we'll have 4 networks or 4 subnets of 64 addresses apiece, or 4 hosts, or 62 hosts apiece. That's a \26. All right, so we're going to borrow 2 bits. All right. I know it's confusing, but yeah, you gotta do it a couple times, and then do it a couple times again, and then it'll start sinking in. All right, considering your answers above, which subnet masks meet both the required minimum number of hosts and the minimum number of subnets required? So let's go over that one more time. All right, so we need, where is it at? All right, so they give us our network, they give us our CIDR, which is 24. We have 1 subnet for LAN A, a minimum of 50 hosts. So 50 hosts would be right there, or 62, right? 62 hosts. All right, second subnet, you need at least 40, so that's fine. We're still at 40. All right, you also need at least 2 additional unused subnets for future network expansion. So \26 actually does both of those. It gives us 4 subnets, it gives us 62 hosts, and 64 addresses. All right, and if you do 64 times 4, that gives you 256. All right, so we know that's good. All right, so when you determine the subnet mask meets all your stated network requirements, derive each of the subnets. List the subnets from first to last in the table. Remember that the first subnet is 192.168.0.0 with the chosen subnet mask. All right. Now, if you did this in this little table, it would be fairly confusing, I would assume. All right. So if we're using a \26, I'm just going to put \26 here. \26. All right, so we're going to have 4 subnets. All right, which that's fine. I'll fill those in. But now, I put this in here, but you don't really need to worry about that for what we're doing here. But network, all right, subnet mask would be a 26. So actually, I'm going to Control V. All right. So 26 is the same thing as 255.255.255. All right. So if I borrow 1 bit, it's 128. Borrow 2 bits is 192. So 192. All right. So that's what we got there. All right. So, and what we're going to do is we're going to do 192, 168, 0, and this is going to be 1. And notice our network, first host address, our last host address. The 26 has 64 addresses total. All right, 62 usable addresses for hosts. So it should be, we should add, it should be a total of 62 here. So 62 or 62. So 1 to 62 is 62. All right. All these will be the same. And matter of fact, all these will be the same the whole for everything. 168, 0. All right. Now the only thing that's going to change, all these will be exactly the same. The only thing that's going to change is going to be that. All right. So broadcast. Remember, it's always odd. All right. And if you notice, each subnet is going to have 64 possible addresses. So 0 plus 63 is 64. So our first subnet address, let me format this thing. All right, we'll do it in red. We'll delete that out. All right, subnet address. So 192.168.0.0. Subnet address. I mean, that's the subnet address, but it goes from there. And I can put --.63. Notice that's my broadcast address. The prefix is \26. That won't change. Subnet mask is 255.255.255.192. And what that makes that relevant to, 256, if you subtract 256 from 192, notice that it'll come out with 64. All right, so we know, I'm going to erase this. All right, 63 was our broadcast for the first subnet. So the next subnet is going to be 64. Notice it's even. So 192.168.0.64. All right, and then it's going to go through, well, we're going to find that out. All right, 64 is our network address. First host address is 65. We know we have 64 addresses total, 62 host addresses. So if we add 61 more, let's do a calculator. So we're starting at 65 plus 65 is our first usable host address. If we add 61 more, that's 126. All right, so that's our last usable host address. Our broadcast 127, that's our very last address in that subnet. And notice it's odd network, even for first host, even for last host. A lot of times people get that confused with the broadcast, but that 126, these are usable host addresses in here. 127 is our very last address. All right, 127 prefixes. The prefix always stays the same. All right, and so does the subnet mask. All right, so now we know 192.168.0. We know 127 was the last address in that subnet, so our network address is going to be 128. All right, so 128. All right, take these out. 129. All right, first usable host address. Notice it's even. All right, it's odd. I've had too much coffee today. All right, so we're going to add, we have 62 possible host addresses. So 129 is our first one. 129 is our first one, plus 61 more, because it's 61 plus that first one, 190. All right, 190. All right, broadcast, 191. All right, that sounds right. Right, 191. All right, actually that's 26. 255, 192. All right, and that actually should be a dot. So 192.168.0. All right, 192. All right, it's even for our network. That sounds good. Let's make sure it's right. All right. So 192, first usable host address would be 193. If we added, right, this is a little bit easier because I know like 255 would be the last, would be the broadcast, because it's the last number in that octet. But anyways, let's make sure that works out correctly. All right, 193 is our first usable host address. If we add 61 more, because we have 62 usable host addresses, plus 61, all right, 254. All right, so 254, so broadcast address is 255. Very last address in here, all right, if we added all those up, is 255. So that makes sense. All right, so this would be .255 backslash 26 255. Whoops. All right, and that's why you don't want to do this with a calculator. I know there are like online calculators and things like that, but you need to understand how that works. And a lot of times what they'll say, okay, you have these four, they'll just give you an IP address, and they'll give you a multiple choice question, maybe an IP address and a CIDR prefix. All right, and let me erase all this stuff. All right, so like if they give you 192.168.0. I'm just going to make something up. .120. I don't know, 129. 29. And they'll say, okay, and it's a /26 because that's what we're working with. 6. They'll say, okay, is a 192.168.0. 164. They'll say, okay, is this IP address on this network? And you look at it and you'd be like, well, yeah, because like class C address, that looks right to me, but actually it's not. All right. This network, which is that network, it only goes from 60.64 to .127. 129 would be on the following subnet, so they would not be on the same network. So that's how they trick you. All right, but anyways, enough of that. Let's continue on. Oh, working on almost an hour. All right, assign IP addresses based on the criteria. Use the IP network settings as an example. Assign the first subnet to LAN A. Use the first host address for the customer router interface connected to the LAN A switch. All right. Use the first host address and that is, come on, what is it? I have to look up here, I guess. All right. Well, sometimes when you mouse over it, it didn't show you. Come on. Alright, for some reason I can't mouse over. I'm assuming that this is probably gigabit 00 on this router, but I'm not really sure. If I did a, well, enable show run. Alright, so I know I have a gigabit 00 and 01. Serial 010 is connected that way. That's fine. And notice we have NAT set up. IPNAT inside, IPNAT inside. So it's natting addresses out, and then you have IPNAT outside. Not a big deal, but for some reason, this happens sometimes on Packet Tracer. See if I mouse over this interface, it won't tell me what it is. So I can't tell for sure what that is. Here's a trick. All right, if you go to physical mode, all right, and I was on one, I think. Where was I? It doesn't show this by default. Like say if you're on, I forget where I was. That's no. Go back, go back, go back. Alright, so it's normally like this, and they have a whole bunch of like cool little things going on in there. Alright, you're in home city. If you click on the house, go to wiring closet, see how this has a rack, and this is simulating the actual rack, like the ISP switch, LAN A and LAN B switches. Alright. If you go down, ISP router, customer router. Alright, so if I click on the customer router, where was it at? If I mouse over that, that's ISP router, this is customer router. Notice how this is the customer router I'm looking for. Alright, notice how it has gigabit 00 LAN A. Alright. So source port. Alright, this source port is gigabit 0001 LAN B. So to LAN A I should be using gigabit 00. Alright, I'm pretty sure, and then the destination is gigabit Ethernet 01 on the switch. Okay, so I'm pretty sure that's right. But that's one way to tell if you can't. Like if I mouse over that, I can't tell. Alright, so let's do Control C. Alright, config T. Alright, so assign the first subnet to LAN A. Use the first host address for the customer router interface connected to LAN A switch. Alright, so interface gigabit 00, IP address. So the first usable host address. And let me just go up here and make sure I'm getting this thing right. Okay, so first subnet will be LAN A. So I could label this LAN A. Alright, and this will be LAN B. Alright, now it makes a little bit more sense. Alright, first usable host address. Okay, is going to be 192.168.0.member.1.0 is the network address. Alright, now subnet mask, remember 255.255.255.member 192. Alright. And I like to have my grading up just so I can watch it. Especially when stuff's not working exactly like it's supposed to. Alright, let's do a no shutdown. Alright, so that looked good. So that's good right there. Alright. Use the second host address for LAN A switch. Alright, you notice we're getting convergence there. Customer interface, use the second host address. Alright, so what it's talking about is the SVI interface. Alright, so enable config T, whoops, config T. Alright, interface VLAN 1, IP address. Alright, 192.168.0. The first one was .1, the second one was .2. We're going to get 255.255.255.192. Alright. Now we need to make sure, put a default gateway in, IP, what is it? IP, gotta remember what default gateway is. Okay, actually, let me do a no shut. Alright, what I gotta do is I gotta back up. Let's exit out of that. IP default gateway, that's going to be the interface for customer router. It's 192.168.0.1, 255.255.255.192. Without that. Alright, that's better. Yep, don't put a default gateway on the end of that. Alright, so that's good. Alright, use the last host address for PCA. Make sure to assign the default gateway address for the PC. Alright, so let's do PCA. 168.0. Remember, the last usable host address is going to be, this is the broadcast address, so it's going to be 62. And notice how it automatically fills in CIDR at 24. We've got to make that a 192. Alright, default gateway 192.168.0.1. Okay, that should be good. Alright, assign the second subnet to LAN B. Alright, use the first host address for the customer router interface connected to LAN B switch. Okay, interface gigabit 01, IP address is 192.168. Alright, .0.65. Alright, and a subnet mask of 255.255.255.192. Alright, let's do a no shut, turn it on. Alright, so let's see, got that. The second host address for the LAN B switch, make sure they assign the default gateway address for the switch. Alright, so let's go here. Let's do enable config T interface VLAN 1 IP address. So that's going to be the second usable host address, which is 192.168.0.64 is the network, 65 was already used, 66. IP, I'm sorry, and 255.255.255.192. Alright, then you gotta back out of it. Alright, and then default gateway. Whoops. IP default gateway is going to be 192.168.0.65. Okay. And did I turn on the VLAN 1? Probably not. So let's do interface VLAN 1. No shut. Alright, so that's good. What if I turn this one on? Yep, I got that one right there, so that's good. Alright, so use the last host address for PCB. Make sure to assign the default gateway address for the PC. Alright, so let's go to desktop. Alright, last usable host address is going to be one less than the broadcast. So 192.168.0.126. Subnet mask is going to have to be changed. All right, default gateway is 192.168.0.1. Oh, I'm sorry. Yeah, see that? You can mess that up easily. All right, 65. Right? 192, let's see. 64, 65. All right, well, let me check my results. PCB default gateway. What did I do? I messed something up. 65. 065. $192. 126. All right. 192, 168. Oh, duh. I do that a lot. 192.168.0.65. Alright, that looks way better. Alright, now we're good. Alright, let's continue to go. Alright, configure basic settings on the PC, switches, and router. Refer to the addressing table for device names and addressing information. Configure customer router. Set the enable secret password on customer router to class 123. And make sure it's probably case sensitive, so make sure it's uppercase for the C. Alright, so let's exit. Alright, host name is going to be, I'm sorry, enable secret. Whoops. Config T. Enable secret class 123. Okay. Set the console login password to Cisco 123. Password Cisco 123 login. Alright. Configure customer router as the host name for the router. Alright, let's exit. Host name is customer router. Alright, that was good. Configure the gigabit 0 and 01 interfaces with IP addresses and subnet mask, and then enable them. I already did that. Save the running config to the startup. Copy. Start. Okay. Configure the two. Fill in the missing IP address in the addressing table. Okay, I did that out of order. Fill in the addressing table. You don't have to do that if you're in my class. But as long as you did that, I configured it right there. But now I want you to configure the PCs, test and troubleshoot the network, determine if PCA can communicate with this default gateway. Let's ping it. Ping 2.168.0.1. Alright, it's good. PCB pin 192.168.0. I think it's 64, 65. Whoops, 65. Okay. Determine if PCB can communicate with this default. Did you reply? All right. So that's it. Man. All right, that was a lot. But yeah, remember that's a good trick I learned a while ago. If you can't mouse over everything, like can't right now, and see what interface it is. If the interface is not assigned with an IP address, you can't really tell. But if you go to physical, go to the, where is it? It would be, it would be the little house icon. But you can look in there and you can mouse over everything and it'll show you what it is. Right? And that is it. Alright, thanks for watching.